Hello everyone, my name is Vrisha Masala and today I am going to present an exciting topic GSM based soil moisture monitoring and automatic water supply system for farms. Why is this important? Agriculture is one of the most essential industries in the world and irrigation plays a vital role in ensuring healthy crop growth. However, manual irrigation often leads to problems like water wastage, over irrigation, and uneven water distribution. These issues can reduce crop yield, waste valuable resources, and increases labor cost. What is the solution to this problem? To address these challenges, we used a smart automated irrigation system that monitors soil moisture level in real time using sensor, automatically controls the water pump to irrigate only when needed, sends update to farmer via GSM, that is mobile communication technology, so they can monitor the system remotely. Why does this matter? With climate change and increasing water scarcity, efficient water management in agriculture is more important than ever. This technology helps farmers save water, reduce effort, and improve crop production. What we will learn in this presentation: how the system works, the components used, the role of 8051 microcontroller, future improvement, and real world application. So let's dive into the fascinating topic and explore how smart irrigation can revolutionize modern farming. Introduction. What is automated irrigation? It is a system that automatically waters the crop based on soil moisture level, helps in saving water and reducing human effort. How does it work? A sensor checks how wet or dry the soil is. If the soil is too dry, the system turns on the water pump, and if the soil is too moist, the system keeps the pump off. Now the problem statement. Now let's take a look at the problem statement and why we really need automation in the irrigation. First, manually watering leads to water wastage. With traditional manual watering, it's easy to use more water than necessary. Farmer might not always know exactly how much water the soil needs, leading to water wastage. This is a huge problem, especially in areas where water is a limited resource. Second, overwatering can damage crops. If too much water is applied, it can lead to overwatering. This harms the crop by causing root rot, poor health plant, and sometimes even crop failure. It also washes away important soil nutrients, making the soil less fertile in the long run. Third, farmer needs a smart system to use water efficiently. Farmer needs a smart system that can monitor the soil moisture and provide water only when the crops need it. This ensures that the water is efficiently used, avoiding wastage and keeping the crops healthy. A system like this can help farmer make better decisions without having to rely on the guesswork. Fourth, the system saves time and effort while ensuring crop get the right amount of water. With automation, farmers don't only have to spend time checking moisture level constantly. The system works automatically, saving time and effort. It makes sure the crop get the right amount of water when they need it without overdoing it or leaving them dry. Objective of this system. What is the goal of this system? The primary aim of this system is to make irrigation smarter, more efficient and automated. Traditional irrigation methods require farmer to manually check soil moisture and turn water pump on and off, which is time consuming and inefficient. This GSM based soil moisture monitoring and automatic water supply system helps optimize the water usage, reduce human effort and improve crop health. Now the key objectives. First, which detects soil moisture level automatically. The system uses soil moisture sensor to continuously monitor the moisture content in the soil. The sensor detects whether the soil is too dry, moderately moist or sufficiently wet. Based on this reading, the system decides whether irrigation is needed, ensuring plants receive just the right amount of water. Second, control the water pump based on soil condition. The microcontroller receives moisture level data from the sensor and processes it. If the soil is dry, the microcontroller activates the relay, which turns the water pump on. Once the soil reaches an adequate moisture level, the system automatically stops irrigation, preventing overwatering. Third, save water and reduce human work. Traditional irrigation methods often lead to excessive water use, which wastes resources and increases cost. By automating the process, this system ensures that the water is used only when needed, reducing water wastage. Farmers do not have to manually check moisture level or operate pumps, which save time and effort. The system also helps in areas where water supply is limited, making farmer more sustainable. Fourth, provide real-time update to farmer. The GSM, that is Global System for Mobile Communication module, allows farmer to receive SMS notification about the system status. They get alerts when the pump turns on due to dry soil, pump turns off after reaching adequate moisture, or if there is any fault or issue in the system. In advanced version, the system can be connected to a mobile app or lot platform, allowing the farmer to monitor and control irrigation remotely. Now the block diagram. These slides explain the block diagram of the developed prototype and how the pump turns off, turn on, and how an alert is detected. Now the components used. Let's dive into the key components. 8051 microcontroller, that is the brain of the system. The 8051 microcontroller acts as the brain of our system. It's responsible for receiving signal from the soil moisture sensor, processing the data and making decision. It sends command to the relay to turn the water pump on or off depending on the moisture level in the soil. Without this, the system wouldn't function as it would lack a central controller to make the decision based on the sensor data. Next, soil moisture sensor, which detects the moisture level in the soil. The soil moisture sensor are responsible for detecting how much water is used in the soil. This sensor measures the soil moisture content and sends the information to 8051 microcontroller. Based on the data received, the microcontroller decides whether the soil is dry enough to activate the water pump or not. These sensors are key to ensuring the system water the crops only when needed. Then OPAMP comparator, which compares moisture valves and makes decision. The OPAMP, that is operational amplifier, acts as a comparator. It takes the moisture reading from the sensor and compares them with a threshold value, that is the ideal moisture level. If the soil is too dry, the OPAMP sends a signal to the microcontroller instructing it to turn the water pump on. When the moisture reaches the desired level, the OPAMP sends another signal to turn the pump off. Next, water pump and relay, which turns the pump on and off. The water pump is what provides the irrigation to the soil. It is controlled by the relay, which is triggered by the microcontroller. When the soil is low, the relay switches the pump on, allowing water to flow into the field. Once the soil reaches the ideal moisture level, the relay turns the pump off, stopping the irrigation. This ensures that water is only used when necessary. Next is the LCD display, which shows moisture level and pump status. The LCD display provides real-time feedback to the user. It shows the current moisture level of the soil and whether the water pump is on or off. This helps farmer or user monitor the system and ensures it's operating efficiently. If the moisture level is too low, they can check the display and see that the system has activated the pump and vice versa. Next is the power supply, which provides electricity to the system. The power supply is responsible for providing all the necessary electricity to the system. It powers the 8051 microcontroller, sensors, OPAMP relay, pump, and LCD display. Without a reliable power source, the system wouldn't function. It's important to ensure that the power supply is stable and sufficient for all components to work together. Now the role of 8051 microcontroller. What does the microcontroller do? First, it receives data from the moisture sensor. Second, it analyzes the data and decides whether the pump should be on or off. Third, it sends signal to the relay to control the water pump. Why should we use the 8051 microcontroller? First, it is low cost, reliable and consume less power. It can easily handle sensor and relay. It is ideal for automation and irrigation. Now, how the soil moisture sensor works. It has two metal rods inserted into the soil. These rods measure electrical resistance. If the soil is dry, high resistance, which means system turns on the pump. If the soil is wet, low resistance, system keeps the pump off. Now the role of relay in the pump control. What does the relay do? A relay is like a switch that turns the water pump on and off. The microcontroller tells the relay whether to activate or deactivate the pump. How does the relay ensure safety? First, protection circuits like diodes are used to prevent damage. This ensures that the system runs smoothly and lasts longer. Now the LCD display and monitoring. How does the LCD helps? First, it displays soil moisture level in real time. It shows the pump status. It helps the farmer monitor irrigation and avoid overwatering the crops. Now the programming and the logic. How does this system work step by step? First, the soil moisture sensor detects dryness in the soil. Second, the microcontroller receives the signal from the sensor. Third, the comparator processes the data and checks if the irrigation is needed. Fourth, the relay turns on the water pump if needed. Fifth, the LCD display real-time updates of the soil condition and pump status. Now, let's walk through the working process of the system step by step to understand how it functions. Moisture sensor detects soil dryness. The process begins with the soil moisture sensor. The sensor is placed in the soil and continuously checks the moisture level. If the soil is dry, the sensor detects this and generates a corresponding signal. The signal is sent to 8051 microcontroller for processing. This step is crucial because the sensor ensures that irrigation only happens when the soil actually needs water. Microcontroller receives the signal. Once the sensor detects that the soil is dry, it sends signal to 8051 microcontroller. The microcontroller acts as the brain of the system and receives the moisture data from the sensor. Based on the received data, the microcontroller evaluates whether the soil moisture is below a certain threshold, that is, it is too dry. If the moisture level is low, the microcontroller takes action and moves on to the next step. Comparator processes the data. After the microcontroller receives the signal, it passes the data to the comparator, which is an OPAMP. The OPAMP compares the moisture level from the sensor with a predefined value threshold. If the moisture level is below this threshold, the OPAMP processes the data and sends the signal to activate the irrigation system. This decision making process is what triggers the next action, turning the water pump on. Relay activates the water pump. Once the OPAMP processes the data and confirms that irrigation is needed, the microcontroller sends a signal to the relay. The relay is like a switch that connects the microcontroller to the water pump. When the relay receives the signal, it activates the water pump. This allows water flow to flow in the field, providing crops with the water they needed to stay healthy. LCD display real-time status. As the system is running, the LCD display provides real-time feedback to the user. It shows two key pieces of the information, the moisture level of the soil and the status of the water pump. This helps the farmer or user monitor the system and ensure everything is working as it should. If the moisture level reaches the desired level, the LCD will also update the status accordingly. Now, this slide shows the developed prototype, how it is used in real life. Now, the advantage of the automated irrigation. First, it saves water, that is, it only uses the required amount. Second, it reduces manual effort, that is, no need for farmer to check moisture manually. Third, it prevents overwatering, which protects the crop from excess water. Fourth, it's cost effective, which saves electricity and water expenses. Fifth, it improves crop yield, which ensures plants get the right amount of water. Now the application of the system are shown in this slide with the help of a beautiful descriptive figure. Now the future enhancement, that is GSM based alert. Farmer receive SMS notification when the pump is on and off. Lot and mobile app. Farmer can check soil moisture level remotely. Third, weather based automation. This system adjusts watering based on rainfall prediction. Fourth, solar power system makes irrigation energy efficient and eco-friendly. Now the conclusion. In conclusion, the automated irrigation system has the potential to revolutionize farming practices. Let's break down why. Automated irrigation is a game changer for farming. Traditional irrigation systems often rely on manual labor or scheduled watering, which can lead to either overwatering or underwatering. Automated irrigation, however, adapts to real-time soil condition and waters the crop only when necessary. This makes it a game changer because it shifts the responsibility from human to technology, ensuring that irrigation is done efficiently, without waste and according to the needs of the soil. Saves water, reduce effort, and increase efficiency. One of the most significant benefits of this system is the water conservation it promotes. By monitoring the soil moisture and only activating the pump when the soil is dry, the system reduces water wastage that is common in traditional irrigation method. It also reduces human effort since farmers don't need to manually check moisture level and switch pump on and off. The system is efficient because it works automatically and operates when required, saving both time and energy. Now, the future improvements will make the system smarter and more effective. While this system already provides a smart solution, there is always a room for improvement. In the future, we could integrate additional technologies to make the system even more smarter. That is, GSM based alert could notify farmer about the pump status via SMS, or lot integration could allow user to monitor and control the system remotely through a smartphone app. Moreover, weather-based adjustment could optimize irrigation by factoring in local rainfall prediction, further improving water efficiency. The inclusion of solar panel could also make the system more eco-friendly and reduce energy cost. With such improvement, the system would not only become effective but also more user-friendly and sustainable. I hope you like my presentation. Thank you.